Creating our own libraries and working with libraries is something that you don't do every day with C and C++ projects, but it can be very useful to have available to you as a skill if you are building a project that's going to have code that's shared amongst modules. The other thing about this is a good opportunity to understand how the actual libraries, like the math library, like the standard library, like all of the libraries that we work with, are actually structured. They have gone through a very similar process to what we're going to go through in this tutorial video in order to create those libraries that we then use in programming our C programs. So to begin with, we're going to create a very simple library. This library here has one function in it. Print message in caps that takes a const char pointer and prints as a parameter. This here is the header file for this project. Notice that we have just this one function prototype declared in here, and we have our comments here describing what the function does, what the parameter is, what the method is doing. We are protecting against multiple includes with the ifs and if not defines. And up top here I have this comment explaining what the file is all about and giving my information about being the author. Now I have an implementation of this file that is given right here. Now you'll notice that this file here again has the comment block up top that begins it, followed by a set of includes. Now you notice I'm putting my includes inside of the C file because there are no includes, or there are no dependency upon external includes in this H file here. Everything that I need can be defined in the C file. That helps to cut down on the complexity of dependencies and is a good practice to follow, to not include additional includes in the header file unless you need them for some data structure. So I have in this case library demo, which is the header file here. I have C-type, malloc, standard IO, and string, which are different pieces of, or different libraries that I am using within this code. Inside of my single method, I check to make sure it's not null, which is a good practice to get into. I calculate the string length. I malloc some space for that string. I set it all to be 0, so this memset basically does a while loop over, initializing all those elements in the array that I allocated here, or the array of characters that is now part of this malloc space, to 0. And I should actually have a char pointer there type def because malloc technically returns a void. Then I iterate over each character in the string that's passed in, converting it to upper and storing it in the string before I print it out and I free the memory. Now something to note, this parameter, this pointer, is being declared const. It's being declared const because I do not change anything that is pointed to by this pointer. That data is untouched. It's read-only, which is why we would want that const to be in front here. So this is my code. This is going to be my library. So what I'm going to do is I'm going to save the project right now. And if I do a build, what we're going to find is it fails, saying that it has an undefined reference to main. That's a linker error. You'll notice that right here we are trying to run the linker. The linker is trying to create an executable program out of this, which we do not need. The compiler, which ran this line up above here, actually created a file called librarydemo.o. That happens to be the object code that is output by the compiler. We can see that by looking in the directory where this code lives, inside the debug directory. You'll see that we have this librarydemo.o file, which is created by this line right here. Now what I'd like to do is take this and create a library that I can use in another program. So to do that, we need to go and issue some commands. So the command I wish to issue is going to create our library using the archiver. Now libraries have some really interesting properties to them. First off, they're created with this archiver, which I can look at the man page for it and see that what it does is it creates, modifies, and extracts from archives. So this will take object code, placing it in an archive file. Kind of like you can do in Java, where you can take a program and combine most of them together into a jar file. It's a little bit different structure, a little bit different behavior, but it's a similar concept. The CR option that's right here says I want to create the library. I'm creating libdemo.a. Now, by definition, all libraries in Unix start with lib and end with .a. The name that we're going to refer to this basically is the center section called demo. The object that I want to place in here is library demo.o. Now, I could have multiple object files that I would put in here, and they would all archive together. I only want one of them at this point in time. So what I'm going to do is create the archive, and we can see that we created this file libdemo.a right here. That is the library that's going to have the pieces of code we need. Now I have, if I close this project down, another project here that's going to use this. And this is kind of the main that you would think of in another program. Basically what it's going to do is call print message in caps. So this is a very, very mundane usage of a library, but it's getting the point across. Now, in order to use this library, what I've got to do is I've got to put it into this project. So I want to take this libdemo.a that I have here, and I'm going to copy this over into my library demo main code directory like so, making sure that I have the A file there. And then I also want to go and copy the header file and put it into that place as well. So now we have the library demo and the library right here in the directory of the project we're going to build. It is possible that you could use pathing and do some other things location-wise so you didn't have to copy these over. For what we're going to do, it's perfectly acceptable to just copy these. A more advanced project, obviously, you'd want to link to them. So what we need to do now is go into our project here. First, I want to do a refresh to get the files. And you'll see that if I try to build it right now, even though I copied those over, it's going to fail because it's got an undefined reference. We've got this linker error here. So to make things work, I first want to add and include to the header file for my library. So library demo.h, I'm going to be including. If I build again, now we're still going to get this linker error, undefined reference to print message in caps. It can't find that function being declared. The library is there, we're just not linking it in yet. So this is a project config option that I've got to do. I go into my properties for my project, and I want to go into settings, and for my linker, which is actually linking things together here, I want to go down and click on this tab that says libraries, and what I'm going to do is I'm going to add the library called demo. Notice I just put the name in, not the .a or the lib that is up front. Click on OK. And then I need to add the library search path where we're going to find this. So I'm going to browse for this here. Here's my share. Here's my repository. This is my main code where the library lives. There's the file right there. So that is the path to where the library is going to be found. I'll apply it. I can do a build all, and of course I can run it, and it says hello in caps. So the library did exactly what it was supposed to do, printing it up in caps. So this concludes this demo on how to create a library and how to use a library, how to set up your Eclipse project to use the specific libraries. If you're using a command line makefile, the steps are very, very similar. They're a little bit different as to how you would actually turn the options on, but the capabilities are in the build or the makefile there as well. So at this point, you should be able to take and create a library from an object file that's in existence using the archiver. You should be able to take and now include a library into a project that you're writing that's going to use that code. That brings this tutorial to a close.